Hello and welcome. We're going to go over this problem today, traverse a graph using the umpire method. So let's get started. So the first thing that we want to understand is the problem statement. We're just given this implementation of a graph, return all of the nodes connected to a particular string node, return a set of names of nodes. For example, here's a graph. We have added nodes A, B, C, D, E, F, Z, and then we have added the edges A, B, A, C, A, D, C, E, E, F, D, F. And then if we call the functions of graph A, it should return the list A, D, B, C, E, F, which is the list of all nodes that are connected to A. So like A is connected to B, so B is in the A is connected to A, so A is in the graph. Or in this set, A is connected to C, so C is in the set. A is connected to D, so D is in the set. C is connected to E and A is connected to C, so E is in the set. E is connected to F and C is connected to E and A is connected to C, so F is in the set. Then D is connected to B, so and A is connected to D, so B is in the set. So that just returns all the nodes that are connected to the start of the node A. Okay, so that basically explains what we're looking for. So let's just go to the problem and write the understanding statement here. So we have input is the start of graph node, and then the output is all in graph, and then all nodes connected to start a graph. So let's match this statement. So we want to know what kind of problems this problem is similar. So there's other graph problems. So we're going to use uh, several lists, and we're just going to be appending lists and things to the graph, and popping list elements to get the edges and the of a connected um, graph to output the nodes. So let's plan for this problem. So first thing we want to do is initialize two visit set list and visited set. And while two visits is not empty, then pop element on to visit. Um, then if it is not visited at visited, and then we want to say if the vertex that we got is in self-that vertices. A neighbor in self-that vertices vertex. If neighbor not visited, then add neighbor to the return visited. Okay, so let's implement this plan. So we have to visit set or to visit list. And then we have visited set. And then we have while to visits. So we have vertex is equal to visit top. And then if vertex not visited, add visit add vertex to visited. And if vertex and self dot vertices or neighbor and self vertices vertex neighbor not visited, then changes it. That we want to return visited. So we're done. Okay, so we had a problem here. So we filled 6 items in the second. So what did we do incorrectly? So we added to visit. Oh, I forgot to add start to visit. Okay, we passed the test. So let's look at the review of this problem in Python. In this Python tutor. So I'm going to step through this code. So we're going to first init self dot vertices. We're going to add the vertices into the list. And then we're going to add the edges to the list. And then we're going to go through subgraph, and we're going to start with the start, which is A. So visit set, well, to visit, we're going to pop the first vertex off the to visit list and to vertex not visited, and then we add visited, add to vertex to visited, and then if vertex is in self vertices for neighbor and self vertices, neighbor not visited, then we add to neighbor to visited or to visit, and then you keep on going um, uh, to the visit, add to the visited list and add to visit until we finally get out of this loop. And we then return this set CAFEDB because those are all the neighbors of A that are visited and have a connected edge to A. Okay, so now that we're done that, we can go back and evaluate what's going on. So evaluation of this problem. So we have an O(n)² time complexity problem here. Since we go through this while loop and then we check to see if it's not visited or it is visited or not. And then it's also O(n) space complexity, since we use the visited sets and to visit to hold the nodes. So that is it for this analysis of this problem. So thanks for watching.